do this, but some of these are a little more complicated, so I'm going to go over these. So you have a negative 1 is less than negative x over 3 is less than 1. And they're asking me to solve for x, graph, and put the solution in interval notation. Okay, so whenever you have something like this, where you have two inequalities and you have the variable in the middle, okay, what you can do is you can just solve it as one problem. Or you could also split this up as this problem here and this problem there. So it doesn't really matter, okay? So we'll solve it as one problem. So negative 1 is less than negative x over 3 is less than 1. So I have to get rid of the 3 here in the bottom, so I'm going to multiply everything by 3. Okay, that means all the way across. So these two will cancel out. So I'm going to get a negative 3 is less than negative x is less than 3. I have to get rid of the negative in the middle by multiplying everything by negative, but remember I have to fill up my inequalities when I multiply by negative 1. So that's going to give me 3 is greater than x. Okay, it's greater than negative 3. So what that really means is that x is smaller than 3 and x is bigger than negative 3. Or in an interval notation, okay, x is going to go from negative 3 to 3. That's interval notation. If you were to graph this, it will look like this. 0 in the middle, negative 3 to the left, open circle at negative 3, 3 to the right, open circle at positive 3, and all the numbers in between 3 and negative 3. Okay, so let's get to number 11, which is a little bit more complicated. So number 11, you have x to the 4th minus x is less than or equal to 0. Well, whenever you have something greater than first power, okay, like second, third, fourth, fifth, or whatever, you have to, and this is an inequality, and you have to do number line analysis. So before we do number line analysis, I have to factor out what I can. So I can factor out an x that will leave me with the x to the 3rd minus 1 is less than or equal to 0. But this is difference of 2 cubes, so I can factor some more. So x times x minus 1 times x to the 2nd plus x plus 1 is less than or equal to 0. When I set this equal to 0, I get nothing. I'll get imaginary numbers, so I don't have to worry about that. So the only other critical numbers I have is that and that. So this gives me x is equal to 0, and this gives me x is equal to 1. And those are my critical numbers. So I'm going to go over here, do number line analysis, okay, and 0, 1, partition here, partition there. Okay, we can plug it in anywhere you want. You know, this is probably the best place to plug it in. Okay, let's plug the numbers in that way. Alright, nothing repeats. So once we figure out one interval, we can go through the other intervals. So let's go through here. Put in a negative number. So a billion, and then another negative. Raise that to 3rd power, still a negative. So 2 negatives, then when we multiply these two negatives become positive. Okay, and if you don't believe that, let's go ahead and try this. Let's put 1/2. Okay, put 1/2 here, and that's positive. And then 1/2 here raised to 1, there's the 3rd power. It's going to be 1/8, and then minus 1 is going to give me negative. So positive times negative is going to give me negative. And of course, big positive is going to give me positive. So we're looking to see where this thing is less than or equal to 0. It's right there. Okay, so my interval notation looks like this. Okay, 0, comma, 1, brackets. So it's a bracket. Now, what does the graph look like? No, graph looks like this. 0, 1, close circle at 1, close circle at 0, and there it is. Alright. Let's check for symmetry. And this is section 2. Okay, what does symmetry mean? Symmetry with respect to the x-axis, y-axis, and the origin. Okay, first of all, a symmetric to the y-axis will look like this. That means when I fold on this y-axis right there, these points right here will fall on these points right there. That means this is symmetric to the y-axis. Okay, and then what does symmetry to the x-axis look like? Symmetry to the x-axis look like this when the graph, okay, gets folded on the x-axis. Okay, these points here, all these points will fall on top of these points. Then we say symmetric to the x-axis. And what is symmetric to the origin? Okay, symmetric to the origin is a graph that looks like this. Okay, so usually y is equal to x to the third. So when you put in a 2, you're going to get 8. And then when you put a negative 2, you're going to get negative 8. So you get exact opposite value of what you have here and here. Okay, that's symmetric to the origin. Well, how do you check that in an equation without having to graph it? Because graphing sometimes can be a little complicated. So let's go to number 2. Y is equal to x to the fourth minus x to the second plus 3. Okay, let's check for the y-axis. Okay, we're checking for symmetry to the y-axis. So how do you check? You're going to take any x, put it in here, into the equation, and if you put a negative x, you're going to get exactly the same thing. So that means if it doesn't change when I put in positive and negative x, or if I put in negative x and it doesn't change, it's symmetric to the y-axis. So let's put in negative x in place of every x. Okay. And simplify, clean it up. So this got, when I raise to the fourth power, I'm still going to get x to the fourth. When I raise that to the second power, I'm going to get positive, so negative x to the second plus 3. And this is same as that. Okay, since it's same, okay, so we say yes. We say yes to the symmetric to the y-axis. Then we also have to check x-axis and the origin, so it could be symmetric to everything. So x-axis. How do you check for x-axis? Okay, this time we're going to replace y and a negative y. And if we get exact same equation, okay, then it's symmetric to the y-axis, or the x-axis. So y gets replaced with a negative y is equal to x to the fourth minus x to the second plus 3. Well, there's not much more to simplify. This is not the same as that, so no, we say no to that. Now how do you check for the origin? Origin is when you check, okay, you have to replace both x and the y with the negatives. So negative y is equal to negative x to the fourth minus negative x to the second plus 3. Okay, and clean it up, and this becomes negative y is equal to x to the fourth minus x to the second plus 3. This is not same as that. Okay, so we say no to the origin. Okay, so this thing is only symmetric to the y-axis. Alright, let's do one more. So let's go to number 5. Y squared is equal to x to the third minus 4x. Alright, let's check for the y-axis. Is it symmetric to the y-axis? Well, we're going to replace every x with a negative x. So y squared is equal to negative x to the third minus 4 times negative x. Okay, if we clean this up, when I raise something to an odd power, I still get a negative. Okay, and then negative times negative is going to give me positive 4x. This is not the same as that, so we say no. It's not symmetric to the y-axis. So we're going to check for the x-axis. So how do you check for the x-axis? So we're going to replace y with the negative. So negative y squared is equal to x to the third minus 4 times x. Okay, when I clean that up, that'll become positive y squared is equal to x to the third minus 4x. Yep, that's exactly same as that. Then we say yes. It is symmetric to the x-axis. We have checked the origin also. Okay, and we're going to replace both x and the y this time. So negative y quantity squared is equal to negative x to the third minus 4 times negative x. Well, this becomes positive, so that's good. But this does not, so we have negative x to the third plus 4x. This is not same as that original one, so we say no to the origin. So no to the origin, no to the y-axis, and yes to the x-axis. Okay, that's how we check for symmetry. Alright, one last thing. Okay, we're going to go to section 3 is easy. Okay, it's pre-algebra questions, so you should know how to do that. So section 4, okay, this is number 4. You're given a piecewise function, f of x is equal to 2x, okay, plus 1 when x is less than 0, and 2x plus 2 when x is greater than or equal to 0. Okay, A, they want you to find f of negative 1. But which one do I use to find f of negative 1? I have to use that because that's negative, and this tells me use that when x is less than 0. So that's going to be 2 times negative 1 plus 1, which is negative 2 plus 1, which is negative 1. And that's done. Let's go to B. B says find f of 2. So that means we've got to plug in 2. So which one do I plug it into? This one, because 2 is bigger than 0, it tells me. So that's going to give me 2 times 2 plus 2, which is going to give me 4 plus 2, which is equal to 6. That's done. So C. They want me to find f of negative 2. So I got to plug in negative 2. Which one do I use? I'm back to the first one again. Okay. So 2 times negative 2 plus 1, which is going to give me negative 4 plus 1. The answer is negative 3. And that's done. Okay, and the last one is f of t to the second plus 1. Alright, so now which one do I plug it in? Well, this is just t squared plus 1. That means I got to plug it into both of those. So I'm going to have 2 times t squared plus 1 plus 1. And then in the bottom one, when I plug that in, I'm going to get 2 times t squared plus 1 plus 2. Okay, but I can't stop there because I also have to plug in for that x also. So I'm going to plug in t squared plus 1 there. So I have to write t squared plus 1 is less than 0, and t squared plus 1 is greater than or equal to 0. Okay, so that's it. Alright, we're going to work on the first 4 sections. Okay.